Hi guys, it's Mrs. Winters. Sorry I couldn't be there today, but I still wanted to help you out with your math. You're doing 2 lessons today. We're still solving equations, and they're still not very complicated, but now we're going to learn how to show our work like algebra students do it. We are first in lesson 2, we're solving equations that use addition, and we by using the subtraction property of equality. You can see, this is an example from your book, and you can see that the subtraction property of equality tells us that if we subtract the same number from each side of any equation, the two sides remain equal. They stay the same. Here, if we just have the number 5 equals 5, well, if I subtract 3 from one side and then 3 from the other side, then I have 2 equals 2. It doesn't change anything. Same thing is true when we have an algebra equation. If I subtract 2 from this side, I have x plus 2 minus 2. The 2 minus 2 makes 0, so I have just x left. But over here, 3 minus 2 makes 1. So then we know x is equal to 1. That's the subtraction property of equality. We can always double check because this is a pretty simple equation for us. If x equals 1, and we put a 1 up here for x, 1 plus 2 is 3. So it's still the same. That either way, we probably can solve this without using the subtraction property of equality, but I want you to practice it. No laziness. Here's an example from your book. It says solve 8 equals x plus 3. So we're going to use that subtraction property, and I want to isolate the x. I want it to be all by itself, so I have to get rid of this 3 here. And since it says plus 3, I'm going to do the opposite of adding, and I'm going to subtract. So I'm going to do minus 3. And that's going to cancel. 3 minus 3 is 0. So I have x plus 0. Well, x plus 0 is just plain old x, right? But anytime I subtract, the subtraction property tells me I have to do the same thing on both sides of the equation. I can't just subtract 3 over here without doing anything on this side of the equation. So on this side of the equation, I also have to subtract 3. And 8 minus 3 is 5. So therefore, x equals 5. I can always check this and say, okay, 5 is x. So if I put it up here, I'm going to check it and say, let's see, I'm checking to see, does 5 plus 3 equal 8? Yes, it does. So I know that x equals 5. Okay, you try it. It's at the bottom of the page. Okay, so it says c plus 2 equals 5. I'm going to use the subtraction property because it's adding, and I'm going to say subtract 2. But if I do subtract 2 over there, I have to do subtract 2 on this side of the equal sign also. So I know that 2 minus 2 is 0, so I have only c left on the left-hand side. 5 minus 2 is 3, so c equals 3. I can always double check that and say, okay, I'm going to take 3 and I'm going to put it up there, and I'm going to say 3 plus 2 and check. Does that equal 5? Yep. So therefore I know c is equal to 3. Yes, you have to show your power with you. So here we have 6 equals 8x plus 5. So I want to get x all by itself. It's called isolating the variable. So I'm going to subtract 5 and get rid of that 5. So I have just x. But then I have to subtract 5 on that side. 6 minus 5 is 1. I can check it Say, let's see, 1, if I put 1 up here, 1 plus 5, yep, it's 6. Good to go. Good? You do letter C and check with your neighbor and see if you showed work my way.